you a little update of what's going on. And yeah, I've been doing some modifying with the Commodore 64C, the white one. You can see it up in the picture above my head here. And well, I did something wrong with the modulator, and now I don't know what's wrong with it, so I have to figure out, and I'm waiting for the scope. Waiting and waiting. And the reason for modifying it was to be able to fix the stripes, if you have noticed it. Well, if you haven't, then you will certainly notice it from now. I'm sorry if you haven't noticed before. The modification is fairly easy actually, but it requires that you do some soldering, and yeah, I'm not going to go into that now. But the other project I'm doing is it's a power protection unit, and you can see also Rick Carson has one, but I didn't like the tweaking and the Zener diode design. So there's a component called the TL431 that is it's like a Zener diode replacement component. So I can show you. Okay, so I'm in at Ray Carlson's archives, and he has this circuit. I think he has more, but this one has a relay on it. Actually, the point of all this circuit is to protect the computer that is connected here from the power supply that is connected here, because when the power supply fails, the 5-volt regulator, if that shorts out, then the regulator's output will be the same as the regulator input. That means this voltage here can rise very fast, and it's all silent, and then your RAM chips or all your chips will fry though. And so what voltage you want here? You want the voltage where the chips that has the lowest maximum ratings, like, and in this case it's the RAM chips. So what I read about this one is that he tweaks it until, and he also has a variable power supply here that he sets it to 5.6 volt, I think, and then he tweaks this one such that the relay turns off. If this one's off, then this is normally closed, and then you will have the 5-volt will not go to the computer, it will go to the fail-safe LED. So that's the working of that circuit. So I was thinking, okay, so the point I was trying to make was that I was using the Zener diode, and it has a soft knee, and that means it should turn on sharply, and it doesn't keep 4.7 volts exactly. It is more like a gliding. I don't know the English, but it means that you don't get exactly 4.7 volt here. So I was thinking, what about operational amplifiers? Well, those are clunky and big, and then you need a reference. But then there's this device that has all this stuff in it, and it's called TL431, and I'll show you that. Okay, I have the datasheet for the TL431. Let's just find the block diagram. It is drawn like a diode, or a Zener diode, but it has this mystical reference input. So how does that work? Well, if you look here, you can see that this point is always 2.5 volt, then the output will be on if the reference is over that voltage, and the output will be low if the reference is below that output, and that is the non-inverting input, and this is the inverting input. So if the plus and minus had been switched around, then it will be the opposite. And that's basically what a ideal Zener diode works, and that is when there's enough voltage here to reach the is it the reverse bias voltage? I don't know. Anyway, when you reach a point, it will turn on. But with this circuit, it turns on very sharply. So it has a sharp knee. I can show you in the characteristics here. So here are some example circuits, and here you can see how sharp it is. So at the bottom there you have the voltage at the cathode, that means the input voltage, and then you have the current that goes through it, and that turns on at 2.5 volts very sharply. So, and this is a cropped image of the same, basically, so you can see what happens around 2.5 volts at the very beginning. So 400 microamps, that's not a milliamp. So yeah, so in many circuits you can actually use this as a replacement for the Zener diode. So yep, it's still a beauty, but I have tampered with it. So let's look inside. And where is the modulator? I pulled it out, and I have it over here together with some other junk. The thing is, they're probably going to run out of space now, but shortly this older was capacitor behind here, and I couldn't replace it. And when I found the replacement, I think maybe there's something wrong with the VIC chip. But I have a new VIC chip, but I want to test it before I do anything more. And I will have to build a new circuit to condition the signal from here to here. So, wish me luck. I may have some new stuff, by the way, a lot that I want to buy, but I'm not sure if I'm gonna get it because the car is on repair. So wish me luck there too. Then I will have a lot of computers to work on. Oh, by the way, I forgot to tell you that we had a party here, a family come together, and my niece, who is 16 years old, she I couldn't help myself. I had to show her the Commodore 64, and as you can see in the pictures, she loved it. At first it was hard and such, but I could see that she loved it. So first we tried Frogger, and then it was Wizard of War, loaded from tape drive. She know all about turboload, and she also now know what diskettes are. She have never seen it before, but you know, it's a different worlds now and then. So okay. Well, it's iPad of mine is running out of space all the time, so I just need to update it. Enough about that. So I'm filming from a mobile phone, and the audio there is pretty poor. So I just wanted to say that summer is coming up, and summer for me is much special because I do have some health problems, and they tend to be much less in summertime, and therefore I can think much more straight. And this is from GadgetUK 164. He suggested maybe that the CIA chips should be CPLD, so I thought to myself, oh my god, I know VHDL, I have done coding in that before, and also digital design. So, and I also looked at the internals of the CIA chip, so I wanted
I really want to do something there and now, learn VHDL and CPLD or FPGA for that matter. So it will be an opportunity to make a difference and learn something new. And yeah, so there will be an opportunity to figure out. And I also found a web page with a CPLD device that you can buy that is only $15, so that's pretty affordable. And then you have to have a programmer, and that also wasn't that expensive. And then you also will need a software pack, development pack. And that's no problem either because you can get that for free. So, and then we'll have to make the PCB board, but that comes later also. First of all, you need to get something that you can work on and develop on. So first you have to figure out all the physical connections, and by that, and also the physical layer. I mean, the device must be handling 5-volt inputs, but it also must be able to do TTL logic outputs. So I think it has to go. And with CPLD you can configure the outputs however you want, and we'll have to look into that. So there's a lot to it, but, and also there's timing though, so I get that right, very important. So I think the first step will be to get the development system of the board, and then get the address line and control bus, the address bus, and the data bus. All that physical layer stuff. Afterward, you don't hurt, you don't burn anything else on that, because the bus itself is the other devices on it, and if you have two drivers on the same line, you will burn something. So get that working, and then you can start work on all the internals and the logic functions. So that something you can use what run chip on, like the PLA. The PLA, that's a logical function, actually. It's like a traffic light. If you set an address, it will decode that address.
You are in scum! In scum!
For a chip that the CPU wants to talk to. But in layman's terms. But with the CIA, that has sequential logic. So that needs some more internal workings than just logical gates. So yeah, I don't think there's very much in there. There's interrupt mask input, and you have registers, of course, so the CPU can write to it and read from it, and then from those registers they control there's a timer, and basically a timer is just a counter actually. When you look at this and you see what these things are,
Hejsan.
noe lignende. Nei da.